You have seen this scene 100 times. A hospital room, a heart monitor, the green line that jumps and then flattens into one long hum. Someone looks up at the clock and says, a time out loud. That is how we picture death. One moment, a switch, on, then off. But it is not what happens when a person dies, and it is not what the machines have been recording. Death is not an instant, it is a sequence. Which raises two questions almost nobody can answer. What is the very last thing you will ever experience? And does a life really flash before your eyes at the end? Or is that just something people say to each other? For most of human history, those were questions for poets. They are not anymore, because over the last 15 years, a few machines have been recording, sometimes entirely by accident, at the exact moment a human brain stopped. And what those machines picked up was not a switch flicking off. It was something slower and far stranger. In one particular way, it was gentler than almost anyone expects. Here is what is actually known, and exactly where the knowing runs out. Because there is an order to this. The senses do not fade together, and they do not fade in the order you would guess. One of them lingers, long after the others have gone. Keep that in mind. It comes back at the end. It starts with the heart. Not necessarily a dramatic clutch at the chest, just a pump, roughly the size of your fist, that is beaten somewhere around 3 billion times across a long life, and then does not beat again. The instant the heart stops, blood stops moving. And blood is the only reason your brain works. It has no store, no reserve tank, no battery hidden in the back. It runs, second by second, on whatever the last heartbeat delivered. Your brain is about 2% of your body weight. It takes around 20% of the oxygen you breathe. It is the most expensive organ you own, and it is funded entirely on credit, delivered fresh, every single second. So when the delivery stops, the lights go out fast. Not over minutes. Within roughly 10 to 20 seconds of blood flow stopping, the parts of the brain that keep you awake stop working, and consciousness is simply gone. You already know how fast that is, because you have probably seen it happen. Someone faints. Blood pressure drops, the brain is briefly shortchanged, and the person does not wobble and lower themselves down. They drop, mid-sentence. That is the same mechanism, only survivable. A faint is a 2-second preview of the first step, and it tells you something worth knowing about the last thing you will ever be aware of. Whatever it turns out to be, it will not be a long goodbye, which is where most people assume the story ends. Heart stops, brain shuts down, and that is that. But here the process does something unexpected, and the whole of modern resuscitation medicine is built on it. The neurons do not die. Not then. Cells starved of oxygen immediately begin to fail, but failing is not the same as dead. For minutes afterwards, they hang on, damaged, silent, and still entirely recoverable. That gap is the entire reason CPR exists. Chest compressions do not restart a heart, which surprises most people. They do something humbler and more desperate. They squeeze blood through a body by hand, keeping a brain barely fed, buying time. The window is roughly 4 to 6 minutes before the damage starts becoming permanent. Cold changes the rules. In very cold water, a brain slows down and asks for less. And people have been brought back after far longer than anyone would think possible. Sit with what that actually means. If the neurons are still alive and the heart has stopped, then the person is somewhere in between. Not living, not finished. Death, it turns out, has a middle. And it is in that middle, in those first strange seconds, that something happens which scientists are still arguing about today. Because the dying brain does not always go quietly. Sometimes it does the exact opposite. In 2013, at the University of Michigan, a neuroscientist called Jimo Borgigian was recording brain activity in rats at the moment of cardiac arrest. She expected what everybody expected. A trace that faded away toward nothing. It rose. In the first 30 seconds after the heart stopped, the recordings lit up with gamma waves, the fast, tight, high-frequency rhythms. And they were not merely present, they were more synchronized, more coherent than in the waking living animal. Gamma matters, and it is worth being clear why. In a healthy brain, gamma is the signature of the busiest kind of work there is. Attention, perception, the stitching together of sight and sound and thought into one single experience of a moment. So the reading said something close to absurd. In the half minute after the heart stopped, inside a brain receiving no blood at all, the electrical signature of intense, organized processing did not fade out. It spiked. But a rat cannot tell you what that felt like, or whether it felt like anything whatsoever. To get any closer, you would need the same recording from a human being, taken at the exact moment of death. Nobody can plan that. It happened anyway, once. An 87-year-old man was admitted to hospital after a fall, with bleeding across the surface of his brain. He had surgery. Afterwards, he began having seizures, so doctors wired his head for EEG and left the machine running to watch him. And while that recording was running, he had a heart attack, and he died. Which meant that for the first time, a continuous trace existed of a single human brain crossing over from alive to not alive, second by second. The team, led by Raul Vicente and Ajmal Zemar, published it in 2022. In the 30 seconds before the heart stopped and the 30 seconds after, gamma activity rose relative to everything else in the brain, exactly as it had in the rats. And there was more. That gamma was locked to slower rhythms, alpha and theta, in one very specific pattern. That coupling is not random noise. In healthy people, it turns up during memory recall and during dreaming. The researchers chose their words with real care, and it is worth repeating them almost exactly. It is intriguing, they wrote, to speculate that such activity could support a last recall of life in the near-death state. Read that again. The oldest story we tell about dying, that your whole life passes in front of you, showed up in a hospital recording as a pattern that looks, faintly, like memory doing its work. That is the closest science has ever come. Now the honest part, and it matters far more than the headline ever did. This is one man, one brain, and that particular brain was about as far from typical as a brain can be. He had a serious head injury, bleeding under the skull, and a brain full of medication. It was about as far from a normal, healthy baseline as a brain can get, with nothing clean to compare it against. The authors listed every one of those problems themselves, which is exactly what good scientists do. Any of them could have produced the pattern. A single case is a reason to go and look properly. It is not a fact you can build anything on. So in 2023, Borjigin's team went and looked properly, in 4 dying patients being taken off life support, with their family's consent. 2 of the 4 showed the surge, concentrated in the region of the brain thought to matter most for conscious processing. 2 did not. Hold on to that, because it is the part that never makes it into the headlines. Half the sample showed nothing unusual at all, and not one of the 4 could ever be asked what, if anything, they experienced. So the honest position is this. Something can happen in a dying brain that looks, electrically, like vivid conscious processing. Whether anyone is home to experience it, nobody knows. Anyone who tells you they know for certain is selling something. Which brings us to the other kind of evidence, the kind that comes with actual words attached. Because some people do reach that middle place, in the gap where the neurons are still alive, and then come back. And a surprising number of them have a story. Among survivors of cardiac arrest, a strikingly consistent fraction, about 1 in 5, come back describing an experience. That figure holds across separate studies, including a large one led by the researcher Sam Parnia. And the reports rhyme with each other. A tunnel, or a dark passage, a light, a profound calm, which people often describe not as happiness but as the total absence of fear, a sense of floating above the body and watching. Sometimes, a flood of memory. And they turn up across cultures, in people who share no beliefs at all, though the details arrive dressed in local clothing. The figures encountered get read as relatives, or as religious ones, depending entirely on who is doing the reading. Neuroscience has plausible explanations for most of this. They are less romantic, but they are genuinely elegant. Start with the tunnel. Your retina is a hungry piece of tissue, and its outer edges are the very first part of it to fail. Starve it of oxygen, and your peripheral vision goes dark first, leaving only the center still working. Fighter pilots pulling hard turns report exactly this, and they report it fully conscious. A closing circle of blackness with light in the middle. A tunnel. The calm may be chemistry, a brain under extreme stress flooding itself with its own pain-killing compounds. And the sensation of leaving the body has been produced deliberately in a laboratory by stimulating one region where touch, balance, and vision are stitched together. And the flood of memory may simply be that final surge, a brain losing the restraints that normally keep it orderly, everything firing at once, meaning and recollection tumbling out together with none of the usual sorting. But be very clear about what all of that does and does not settle. It offers a mechanism. It does not prove there is nothing more going on. Finding the machinery behind an experience is not the same as showing the experience was never real. Science can describe what a brain does. It cannot yet say what anything is like from the inside, for anybody, alive or dying. On the question of what comes after, the instruments are completely silent, in both directions. So leave that question exactly where it belongs, which is open. Because there is one more finding in all of this. Quieter, far better supported, and possibly the most human fact that science has ever turned up about dying. In 2020, at the University of British Columbia, a researcher called Elizabeth Blunden and a professor named Lawrence Ward walked into a hospice in Vancouver carrying EEG equipment and asked families for their permission to record. They played tones and patterns of sound to patients who were still conscious and recorded how each brain responded. Then they came back and did it again, with the same patients, once those patients had become unresponsive. In some cases, hours from death, the brains answered. In some of those unresponsive patients, the brain's response to sound looked much like the response measured in healthy young volunteers. The sound was still getting in. Something in there was still processing it, in the final hours of a life. Blunden was careful about what that means. Their brains responded to the sounds, she said, but nobody can possibly know whether they were remembering, or identifying voices, or understanding language. No one is claiming comprehension. The claim is smaller than that, and heavier. The door was not shut, which happens to fit what nurses and hospice workers have quietly insisted for generations, long before there was any evidence at all. Sight goes, speech goes. Hearing seems to hang on the longest of all of them. So picture that room again, the one from the films, with the monitor and the flat line. Except now think about the person leaning in close, holding a hand, saying the thing they were most afraid they would never get to say. They will never know whether it landed. There is no squeeze back, no flicker, no sign at all. But the best evidence available says the sound was reaching a brain that was still, in some quiet way, receiving. That is not nothing. That is a great deal. And then, afterwards, the fading carries on. The body does not switch off either. It stands down, unevenly, one system at a time, at wildly different speeds, and it takes far longer than the paperwork suggests. Corneas stay usable for hours. Some tissues last considerably longer than that. It is precisely why transplantation is possible at all. Cells with modest oxygen needs simply carry on with their work, briefly unaware that the organism they belong to has ended. And stranger still, in mice and in zebrafish, researchers track gene activity for up to 4 days after death. More than 1,000 genes changed their behavior, and many of them did not fade at all. They ramped up, switching on hours after the animal had died. Genes for inflammation, genes for immune defense, and, oddly, genes normally used in the building of an embryo. Cells with no more instructions coming, still doing what they had always done. At the smallest scale, death is not an event. It is a long, uneven withdrawal. So go back to that monitor one last time. The flat line, the time spoken out loud, the clock on the wall. That line marks something real, but it marks a beginning, not an end. What follows is a letting go, in order. The body stands down slowly. The senses dim one at a time, not together. And hearing seems to wait at the door longest, so the last thing to reach a person may simply be the voices of the people who came. And perhaps, and it can be put no more strongly than perhaps, one last flare in the dark, as a brain turns inward for a final look at the life it built. Nobody knows. But it is far quieter and far stranger than a switch.